Hello, and this is going to be an introduction to oceanography unit, whatever the heck it is. I'm in Pompano Beach, Florida right now recording this one. But this is the C unit, I think. Really should check YouTube for that. But anyway, we've already talked about water. We've talked about how salt gets in water, how we measure salinity, how salinity is actually measured here. And if you take a look, we've got it in parts per thousand. So we've got all that information on there. So now we're going to talk about how it changes. And salinity changes by basically adding or removing water. It has nothing really to do with the salt, even though we get tons of salt added to the ocean every year. Because the ocean is so large, it has such a small effect. So it really is the adding and subtracting of water. The way you can decrease salinity is by actually having more precipitation or snow. And again, with the ocean makes up 71% of the surface, so whatever is going to rain or snow most likely is going to fall on an ocean. Adding more water decreases the ratio of water to salt, so salinity decreases. You can also have that by once the water actually hits the land, which is 29% of the surface, and runs off, it collects in the ocean, or can actually percolate into the ground, come into the ocean as groundwater. Or we can actually have melting of snow. So the ice that you see up here in the north and the stuff down here at the south, when it melts and rolls into the ocean, that is going to decrease salinity. How do you increase salinity? Here's another diagram actually showing you decreasing salinity by actually precipitating, running off, and groundwater and melting of ice. And then you can increase salinity by evaporation, taking water out of the ocean. Formation of sea ice, actually taking water out of the ocean. The ice that's up there, the snow that's up there, if you've ever had snow fall on your lips, even if that came out of the most saltiest ocean, it's pure water. And then the hydrologic cycle actually describes the recycling of water. This is a water cycle showing it moves both directions. And I showed you a larger one beginning. Again, we have the evaporation, which is going to increase salinity. We have precipitation, which is going to decrease salinity. We have runoff, which is going to add water, decrease salinity. We have more evaporation, which really increases salinity out of lakes, but there's not much salt in the lake. Horizontal variations of salinity. Polar regions, salinity is lower because we have lots of rain and snow along with runoff. Mid-latitude, salinity is high because we have a high rate of evaporation, very little precipitation. And the equator, salinity is very low because of lots of rain. And thus salinity at the surface varies primarily with latitude. Salty, very little salty, pretty high salty, and very low salty. And if we take a look at a diagram, this is called the sea surface salinity map. And we actually go from very, very, very not salty to incredibly salty. And if you take a look, we have salty, and we have not so salty, and we have not so salty. So we actually do have lots of colors, and you see some of these lakes actually no salinity, and that's where we're talking about 5 parts per thousand rather than 40 parts per thousand, which we get in some of these very high evaporative areas. And I got those from this link down here. If we take a look at the map and take a look at the equator, we actually see that salinity drops down because the temperature is so high. We get evaporative counts, but we also get lots of rain along here, so that actually takes care of the temperature and actually makes salinity lower. And then as we go up to mid-latitudes, Tropic of Cancer, Tropic of Capricorn, we actually see that salinity does increase, and you see temperatures do decrease. So it's not having to do so much with temperature, it has to do with the actual precipitation. Lots of precipitation, lots of precipitation. And the relative amount, when I say lots of precipitation down here, we're talking about hundreds of inches per year. And we talk about lots of precipitation up here, we're not talking about as much, but we're talking about in terms of locations up here versus locations where we live, they get more precipitation. But a lot of it's going to end up as a solid form. Vertical variation salinity. The surface of the ocean salinity is variable. Deeper ocean salinity is nearly the same. So whether you're in the tropics or the subtropics, or you're in the polar or subpolar regions, if you go down to the bottom of the ocean where the temperature is 4 degrees, we find the salinity is almost the same. Up at the surface, it's going to change again based on water, whether you're putting water into the ocean or taking water away. Polar source regions for deeper ocean water, the poles pretty much feed the deep ocean and keeps the salinity the same. We have what's called a halocline. Halo meaning like halite, salt, line. It's a rapid change of salinity with depth. And here is the salinity halocline. And if you take a look up at the surface, this water right here, which they're saying is the tropics, salinity is low because of high rainfall. But if you go down into the ocean, salinity is increased very quickly. That is a halocline, and it actually goes down. So you see these lines are all pretty much the same down in the deep ocean, regardless of whether you're at the equator, the tropics, or you're at high latitudes, polar regions. Polar regions, salinity is pretty high because we're taking water out because of ice, and the salinity, we actually get lots of precipitation up here and melting of ice. This is not so much the poles, but we're talking about 60 degrees north and south. So salinities are low because of all the precipitation. But again, salinities increase as we go down because of the polar regions, which I wish they would have shown you up here, because it pretty much is straight up and down here, because of the temperature at the surface is about the same temperature as the temperature down here, 4 degrees Celsius. Density of seawater varies from almost fresh. We have high river runoff or high precipitation to looks like 300% greater. This is grams per cubic centimeter. 1.0 is pure water, so this is almost pure water, and this is like 300 more salt. So it actually does give it more density. Ocean layering according to density. Density in seawater is controlled by temperature. Higher temperature makes water expand, it makes it less dense. Salinity, adding salt to it, makes it more dense, and pressure, pushing them together, makes it more dense. But the big thing is, again, rainwater. But the most important influence, of these three is going to be temperature. Decrease density increases. Density increases is usually with a decreasing temperature. We make the molecules closer together, it makes it more dense. This is the Earth's sea surface temperature map. And if you take a look in terms of temperature, the equatorial regions, we have an El Nino, so we actually do have even warmer water in here coming out from this area right here. It's a much larger bulge of warm water. Pacific Ocean, being the coldest ocean, doesn't get as much warm water, but if we get a influx of air moving from the east coast of Asia towards the west coast of the United States or South America, it blows this water across. In this year, 2015, and actually now 2016, we actually do have a pretty good El Nino brewing up there, and we'll talk about it soon. Cold water, warm water, in between, and you can see there's a pretty good banding in both hemispheres, north and south. Salinity, greatest influence on density in the polar oceans because it is so cold. We have what's called a pycnocline. Pycnocline actually talks about the rapid change of density. So we're going to talk about temperature, we're going to talk about salinity, and we're going to talk about pressure, all in the pycnocline. Remember, we have a halocline, and we also have a thermocline, which is the rapid change in temperature. You ever jumped into a lake after dabbing your feet into the surface, you may actually find out that the water is kind of warm, and you jump in and you find out that there's actually a rapid decrease in temperature. That's the thermocline. And a lot of times you can actually, and I did this as a kid, you could take your hand and feel the warm water, and you could feel it warm, and then you drop it like 6 inches, and all of a sudden it feels very cold. And you understand why it now is feeling cold. Polar oceans are what are called isothermal because it's cold at the surface and it's also 4 degrees down at the bottom, and there's a very small temperature change. If you're in the tropics, it's maybe very warm at the surface, and I think I can actually show that to you. Actually, this is the Earth's sea surface density map, and you can see the densest water up here in the North Atlantic, and you can also see it down here in the south, actually the Southern Ocean, but the very southern latitudes. You can also see very salty water in the Mediterranean Sea. High salt, low salt. Light color, low salt because of all the rain, and up here, because we're also pulling all the water out as ice, makes it very, very dense, and it's also very cold. So if you take a look at the equator, very warm at the surface, but very soon after you drop down in depth, it starts cooling down. It cools down very quickly. That's a beautiful thermocline, which is what this is showing. And if you go to the poles, almost no thermocline because the water actually starts up being very cold and it goes cold. And you notice that all the oceans eventually gets cold. So no matter where you are, with the equator, the tropics, or high latitudes, water pretty much down here at the surface. This is why this is isothermic. Layers of the ocean. We have surface, a very beautiful surface area located next to the equator. We have a surface layer also in the tropics, and at the poles we have a surface layer, but the surface layer is very different, or not very different from the rest of it. And if you look at all three, as you get down, densities are the same, again because of salinity, because of temperature, and because of pressure. Mixed surface layer, pycnocline, where you get a rapid change in pressure. Deep ocean, pretty much the same pressure all the way through. And then the last slide of Unit 6, where we talk about water and seawater. These are all the cycles that go through. You can talk about ozone depleting gases, which are way up here, the CVCs. If you talk about oxygen, you can get oxygen going out of the ocean. You can also get it coming off the land. Sulfur dioxide, photosynthesis, respiration, carbon dioxide, nitrous oxide, sulfur dioxide, water, all these cycles going through. And it's a very, very, very complicated cycle, but we've got things that go up and down and up and down. And if it goes up here, probably goes down over here. And if you take a look at it, the beautiful cycles on the planet. And what basically is changing this is the fact that we have not always had cities. We're actually not always had swamps, or we had more swamps or less swamps. We have lots of sewer, adding urea. We deforest things because we want farmland. We throw up lots of fossil fuels and gases up there, which is causing all kinds of problems. Looks like we are the issue. Okay, that is the end of the unit. So thank you for stopping by, and that should be it. Bye-bye.